Hello everyone, let us now discuss how can we solve this problem. You are given a non-negative integer n representing 2 power n into 2 power n grid. You must fill the grid with integers from 0 to 2 power 2n minus 1 to make it special. A grid is special if it satisfies all the following conditions. All numbers in the top right quadrant are smaller than those in the bottom right, and bottom right are smaller than those of bottom left, and bottom left are smaller than the top left. Each of its quadrants is also a special grid. Return the special 2 power n into 2 power n grid. Any 1 into 1 grid is special. So what I am saying is, what they are saying is, consider n is equal to 1. Now how do we construct this special grid? Is nothing but just start with 0. I am just starting with 0. You can start with 1 or anything, but it should be special, right? Representing you must fill, and sorry, it should be from 0 to 2 power n minus 1, so you need to start with 0. So I need to place 0 and then 1 and then 2 and then 3. They said top right top right is less than bottom right. So this is less than this is less than this is nothing but bottom left, and it is lesser than top left. It is lesser than top left. So this is the condition. So I'll place top left, but before that let me go from top right. So top right is the most least value, which is 0. So top right I'll place a 0. I'll remove this firstly. So top right I got 0, and then bottom right I got 1. I placed it, and bottom left I have to place 2, and then top left I placed 3. So this is one grid, right? Now what if n is equal to 2? I need to consider the same grid with another structure. I'll tell you what will be the structure. So consider this grid, and now n is equal to 2, so it will be 4 columns and 4 rows. 2 power n into 2 power n, which is n is equal to 2. Then 2 power n will be 4. So here n is equal to 2. Now what I did, firstly I take this one and filled it, and I took this one. After this I took this one and filled it. After this I took this one and filled it. After this I took this one and filled it. Now I'll do the same thing here. So this I'll make it a half. I'll make it a half here. I consider this as the quadrant again. Then after this, wait a second, after this it will be here. Then I am considering this as a quadrant, then considering this as a quadrant, and then this as a quadrant. But let me go again here. Now I think I start with the value of 0. Now n is equal to 1, which is nothing but the size of the quadrant. I'm telling you that the size of the quadrant. Now I take the value as the value which is starting for this quadrant. For this quadrant, value will be 0. Value plus 0 into quadrant size. The quadrant size, I'll tell you what it is. Quadrant size will be placed at this at here. So here it will be placed this one plus 0 into quadrant size, and then here we'll place 1 into quadrant size. I'll tell you, I'll write it here. Value plus 1 into q size. Q size, as I said, q size is nothing but n. Now I'll place value plus 2 into quadrant size. 2 into quadrant size. Now here I'll place value plus 3 into quadrant size. Now let us see what happens if I apply the same logic I applied here when n is equal to 1. I am applying the same logic here. I am telling you that it will work. Now what I am saying is, just consider this as a quadrant. Don't consider this as a matrix, just consider this as one quadrant. Now Here when I say this as value plus 0 into quadrant size, I am saying nothing but I am saying it the starting value for this quadrant, the starting value for this quadrant, the starting value for this and for this. So let us see how it is. Value will be 0 initially. Value will be 0 initially. Now here for this quadrant I am saying that value is 0. 0 plus 0 into quadrant size is n is equal to 2, right? N is equal to 2, so 2. And then again 0 plus, now I have 1 into quadrant size. 1 into the quadrant size is 2, right? Now I'll get 1 into 2 is 2. I'm considering the whole quadrant size. This is the size of the quadrant, which is 4. So value is 0. 0 plus 0 into the quadrant size is 4, as I said. And I'll just copy this and I'm just changing 1, 2 and 3, right? I'm just changing 1, 2 and 3. 1, 2 and 3, right? I'll remove this 1, 2 and 3. I'll place the 1, 2 and 3. 1, 2 and 3. Now here I have 0 into 4 is 0 plus 0, it is 0. So I mean here I'll start with 0. I'll tell you what will happen for that. Now I have 0 plus 1 into 4. So I'll start here with 4. Now 0 plus 2 into 4. I'll start here with 4 into 2, 8. 4 to the 12 plus 0 is 12. So here I am considering it as 12. Now when I am here, I got this 0. That means I am considering a quadrant of this one. And as I got the value as 0, I come to this function again, and again and again. Now here it will start placing here 0, 1 and then 2 and then 3. That's how this works. Q size is nothing but the quadrant size. Now what I am placing, where I am placing this value plus 0 into quadrant size, I am placing it when I call x comma y, which are 0 comma 0. I am placing it, I am calling or initializing with 0 comma 0. I am calling with 0 comma 0, but placing this one, right, this one at where I am placing it, I am placing at x comma x is nothing but 0. So 0 0, well, let me name it, give the indices x comma y plus where I am placing it 1. 1 is nothing but 2 by 1, which is nothing but half. Here half is nothing but half is equal to size by 2, size by 2, right? So this is how it will be placed here. And then x plus half, I think x plus half and y plus half, I'll place it here, x plus half and y plus half. And here I'll place x plus half comma y, right? Here x plus half is this and y is this, right? And then here I'll come to x comma y. That's how you solve this problem. And let me write the recursive code. And here when the size is 0, if the base case is size is equal to 0, and I will place answer of x comma y is equal to value. That's it. And then I'll return. Now I'll call this a recursive function. Wait a second. This recursive function with int size, int x, and then int y, and also vector. Let me name it as vector of int of answer, right? I think it's clear till now. Yes, I need to initialize value. Now I'll call this in the main function. In the main function I'll call with recursion of the size is nothing but 1 left shift n, and x is 0, y is 0, and answer is the matrix or the grid we need to return, and the value is also 0. We'll be returning the answer, right? Here I'll call the recursive function with uh, this one, value plus 0 into quadrant size, right? Further, q size q size will be size by 2, right? It is nothing but, sorry, q size will be half into half, and half is nothing but size by 2, right? I think it's clear for you. Recursion of size is now half. Size is half now. Size is half, and x comma y. Every time I am taking this x comma y plus half, x plus half, y comma y plus half, x plus half comma y, x comma y. And I'll tell you how it is. Just name it as x comma y first thing, and answer, and then value is, a value is changed as value plus 0 into quadrant dot size, but here plus 3 into quadrant dot size, plus 3 into q q size, right? Now I am just copying it here and then pasting it over here, right? I am pasting it over here. Now let me change, do the small changes here too. It is 1 here, it is 0 here. X plus half, x plus half comma y, and here plus half comma y, plus half comma y, and then here itself only half comma y. I think it's clear, right? No, I mistook somewhere. X comma y plus half, x plus half comma y, x comma y plus half, right? Yes, that's it, the code. And if you want, I'll tell you how this recursion of function works. Let me take the same, but here I am taking, like, I'll tell you what I am taking here, right? Now I have this matrix, right? I need to do something, do this matrix as special. So here I am starting with 0 comma 0. I am starting with 0 comma 0, and then I'll go to 4, and then I'll tell you where I am going. So 0 comma 0, and the size is 1 left shift n is 4. The size is 4, and 0 comma 0, and the value is 0. I am initializing x, y, and then value. Here it is size. So it will call, it is going here, and size is it, sorry, it should be 1, right? Sorry, if size is equal to 1, then I am stopping there itself. Now 4 comma 0 comma 0, half is equal to size by 2. Now I am calling for half comma x comma y plus half. I'll tell you, half is nothing but 2, x is same, y plus half is 2, sorry, x is 0, right? X is 0, y plus half is 2, so 0 comma 2, and value plus 0 into q dot size, 0 plus something, it's 0, value is still 0. Now here it will call with the size of 2 again. It will call with the size of 2 again. It will call with the size of 2 again. But now x plus half comma y plus half here. X plus half is 2, y plus half is 2, and the value is 4, right? I think it's clear for you. Q size is 4. Q size, if you see, 2 into 2, it is 4. 1 into 4 is 4, right? I think that's what I did here. 1 into 4, here it will be 0, and here it will be calling with 0. That's what going on here. X plus half comma y, 2 comma 0, and the something like 8. Now here it will be 0 comma 0, and I am calling for 12. Now let us see what happens here. Now size will be 1, right? I need to take a bigger tree. Wait a second, sorry. I need to take a bigger tree. Here 2 will be half the size is 1, 1, 1 and then 1. It will be 1 here, it will be 1 here, and then it will be 1, 1 comma 0 comma 2. So x comma y plus half, x comma y plus half. I'll tell x is 0, y plus half, 2 plus 1 is 3, and the value, let me tell you what's the value 0 plus 0 into q size is 2, 2 into 0 is 0 plus value is still 0, right? Is still 0. Now plus half, x plus half is 1, 2 plus 1 is 3, and here I am placing 1, right? 0 plus value is 0 plus 1 into q size, 1 into 1 is 1 plus 0, 1. Now I have again x plus half comma y, x plus half is 1, y is 2, and value is 0, 0 plus 2 into 1 is 2, so it is 2 here, and here I have 1, right? Now it is for 4 x comma y, right? X comma y is 0 comma 2. I'll tell you what will be the value. Value is 0, 0 plus 3 into q size, 3 into 1 is 3. Now I'll tell you at this point of time you can fill all this recursion tree at this point of time. Now I am calling with the size as 1, with the size as 1. Now size is equal to 1. Answer of x comma y is equal to value. Answer of 0 comma 3 is equal to 0 comma 3 is equal to value. What is the value? 0. Now let me give the indices for this special matrix, special grid 0 1 2 3, 0 1 2 3, 0 comma 3 I got 0. Now 1 comma 3 I will be having 1, right? This is the value, this is x, this is y, and this is size. And when we are calling with size is equal to 1, if size is equal to 1, answer of x y will be the value. Now 1 comma 3 I will place 1 here, 1 comma 2, 1 comma 2 I'll place 2 here, 0 comma 2 I'll place a 3 here, right? I think it's clear for you. Now with the same thing with the 4 here for this matrix, this sub matrix of quadrant, let's start with 4 5 6 7. Now for this 8 again 8 9 10 11. For this 12 13 14 15. I think it's clear for you now. So this is how you solve this problem, and I have given the link of the code in the description, and you can go and check it. And if you like this video, do share it to your friends and do subscribe to my channel. Thank you.